Once in a while in engineering, you get those subjects that are just full of words with no calculations, just theory, 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 and you just have to cram. This subject right here is one of them. I've been sitting here since 6. It's now 23, 21, and I'm not confident that I actually know what is going on. I've given up on studying while sitting down, and I've decided to use my standing desk. Hopefully that will work, but seriously though, why do they do this to engineering students? Should this really be what we're doing? So automation is not bad. I can understand why some aspects are there. It is applicable in electrical, but still, this is the type of things you sort of learn or get into, much like common knowledge after doing it for a while, not necessarily cramming and not knowing why you're cramming. I mean, look at this. I'm not sure if you guys can see. Okay, hold on. Let me check quickly. I think you guys can see. Anyway, you've got this whole this is all page 15, 13. You've got this whole thing, all these words. Let me just look at this. All these words to cram. And by the way, this is just unit 1. There's 6 of them that you have to cram. So it's one of those things. Hopefully my studying desk will help, because right now this is not working. And if you're wondering why I'm in this getup, well, right now it's the 4th of June and winter decided to become very, very cold out of nowhere. So that's why I'm in this getup. But let's hope I can finally start studying. Hopefully I'm in the frame. If I'm not in the frame, then I'm not in the frame. I'm supposed to be studying after all. Okay, so unit one. Okay, but admittedly, I have been reading. Only problem is that there's a lot of, those you read, you sort of understand what's happening, but you need to properly understand, know and memorize what's actually written and what's actually said. So that's the problem I am facing. Okay, but there's way too many words. I wonder if I'm actually going to study able to understand. I also decided to play some lo-fi in the background, because apparently that helps with focus and studying. So most of the things that I've tried are not working that normally work. So maybe this will work. Is this a bad time to try it? Probably, but this is what I have. Okay, so here's what I decided to land on, right? I decided to ask myself questions on subject matter in a sense, and then I'd use the thing to refer. So here's an example. I asked, what is automation? I said a few examples of automation is getting a robot to do something for you, or making a robot do repetitive tasks. And one of the answers I got from the slides was the process whereby a machine is given commands with an automated feedback control to ensure proper execution of the instructions. The resulting system can operate without human intervention and not making a robot do repetitive tasks. So guys, allow me to show you this interesting graph that I found while studying. Still on, let's see, the 8th page of the 75. Well, at least I'm making progress. Anyway, I'm finally understanding what all of this means. Yes, I mean, engineering, we're in the system. Okay, system is not the right word, but anyway, we're in the system of learning the day before the test. We don't revise. We learn the day before the test. Anyway, we've got input transducer, which is an input sensor. You've got a controller, and you got a processor, and then you got a feedback. And you got this plus, minus, plus, plus. What does that mean? And if you wrote the test with me and you're also saying this, well, I apologize. But anyway, okay. So we've got an input sensor, and then we've got this thing. Then we've got a controller, which is what, let's say, changes the input and outputs. It changes the output to a processor, and then we've got the outputs here. Then we've got a feedback. Now, so we've got an input transducer, let's say in a general sense for the first time once it's working. We've got an input transducer, the input transducer goes to the controller. The controller does the same thing. It just outputs as well to the processor. Now the processor has, let's say now the controller has an output, right? Now let's say that output, there's some disturbances in the environment and so on. That's why here it's a plus. So you get a plus, you've got some disturbances. That disturbances now gets exported. Get right here, man. That's not the right word as well, but anyway, that gets exported into your output signal. So that means, for an example, let's say you have let's say you have a controller, right? Now that controller has I'm gonna use current. Now that controller has a current of it outputs a current of say 15 milliamps anyway. We've got 50 milliamps. It outputs a current. This is very so I'm gonna put it down. So we're gonna current, right? It inputs a current. No man. It outputs a current of 15 milliamps, right? Now you've got some, let's say now, disturbances from the external environment. You've got some disturbances. Those disturbances now input say 1 or 2 milliamp. Let me check if I'm recording actually. Yes, seems I am. I'm studying with YouTube, because if I studied normally, I would not study or understand. Back to what I was saying, you've got an output of signal of 50 milliamps, let's say, and then you've got say 2 amps of disturbance. So you want an output of 50 milliamps, but then you've got a disturbance of 2 milliamps. Now your output is 70 milliamps. Simple math. Now, so you've got an output, right? Now you've got a feedback element. Well, that feedback element, right, it takes your output signal, and then that output goes to the feedback element. Now your feedback element checks how much is, what's the difference between the input that it gets and the output. What's the difference between the input and the output? And then that gets sent to your summing junction. Now you've got, so once back again, now you've got the signal running in, let's say for the second time, you've got an input transducer releasing, and then it's the input sensor minus the feedback. Now why is it minus? So let's say here you've got a 17, right? Actually, wait, does this make sense? Okay, it should it? Okay, yes. Anyway, the way I understand it, right? You've got your input transducer is releasing an output of 15 milliamps. Now this is very painful. Now you've got an input transducer releasing 15 milliamps, and then you've got a feedback. In this case, let's say your feedback is, suppose there's 2 ways you can do this, but let's just say in this case your feedback is checking your input and your output. So your feedback, your input say was 15, output was 17. Now you've got 2 milliamps right there, and then you've got, so what you have then is 15 minus 2, which gives you 13, which is less, right? But then you've got a 13, so you've got 13 milliamps. Now your disturbance, remember, is 2 milliamps, so you've got 13 plus the 2 milliamps, and you've got 15 milliamps, which is what you want. Now let's say your disturbance changes again from, let's say, 2 milliamps to now 4 milliamps. So you've got 13 coming in. Now 13, instead of 2, it's 4, because that gives you 17. That now gets back into your feedback element. Your feedback says like, whoa, okay, this is now a difference. Now we're back to 17 instead of 15. So the feedback is going to change to, let's say, 4 in this case, because the difference between the input and the output. My input in this case is 13, my output is 17. So it's gonna say 4, now it's gonna say 13. No. Okay, let's just say my input is 15. Then I want a controller was 7 plus 13. So now it's 15. Feedback is 4. So feedback plus 15 minus 4, that becomes 11. 11 gets through. This is the problem with wearing gloves. Now, so input is 15, feedback is minus 4. So you got 15 minus 4 into your controller. Your controller says 11. So 11 plus 4 disturbance, that gives you what you call 15. Does it? Yes, it does. 11 plus 4, that gives you 15. That's the output signal. And this is our control feedback loops on page 8. Now I've got another interesting thing to show you. So we've got this graph over here. We've got programming automation, flexible automation, fixed automation. You've got a production quantity and a production variety. Basically, the more variety you have, okay, let's think about a production plant, right? And say in this case we're producing car doors, for example. So in our car doors, the more, let's say, now if car doors is the one thing we're producing, right? Meaning that our product variety is low, which is just one, because we're just producing one car. We're just producing one thing, which is a car door. That means we can have much higher production quantity on that plant, because then now you're producing, let's say, 1 million car doors instead of one, because you have one thing. That one machine does one thing, which is where fixed automation comes in. Fixed automation is just automation in the sense of everything is fixed in the thing, everything is fixed in the plant. You're not moving anything. There's no product variety or any changes to the automation. You just program it once, and then that's what you get. So it's fixed automation. Now say what to add. car doors and car windows. These are bad examples, but anyway, you've got car doors and you've got car windows. Now we've got a much more production variety, meaning now there's two separate machines. Now we've got two different types of machines creating our production. Wait, you've got two different types of machines that are working to produce the quantity that you have. So you've got car doors and you've got car windows. That means now on your production plan there's less space to just make 1 million, and in this case your production quantity now goes down to 10,000. Now flexible automation, what that means is that so let's say now your machines are programmed to just create one type of thing, which was a car door, but now you program it to now use Windows now to create windows, which thinking about it, like I said, it's a bad example because those two don't switch, but that's what we're working with for now. So you program from car doors to windows now, but it's flexible in the sense that you can create this and then after that create something else. But in your production plant, you don't have that much. Your capacity now is split between your car doors and your car windows, which is why your production quantity goes down. And lastly, we've got programmable automation. Programmable automation meaning that your machines can do a variety of things. Car doors, car windows. How am I running out of examples for car things to make? And I literally have a car image in my mind. But anyway, you've got car engine parts, you've got car flywheels, you've got car doors, car windows, car bonnets, etc. You can program your machines to do a lot of things. So that's what it means by programmable automation. You can move in between many different things, which is why now your product quantity is low. Product variety though is high because you're doing many things. With a fixed automation, what you've got is that you've got a high production cost because you're using a lot of machines to set up and to batch and to create to create 1 million products. Flexible is now on the medium product cost variety because you're making less products, and then programmable is a lower cost compared to your fixed automation, because you batch producing, you're not producing everything just once. So normally when you use a fixed automation, let's say you're producing car doors, we want to create something. This plant will create car doors forever, whereas in your fixed, it's creating a few different things, but it's not just one thing set on this. So you're not, as someone designing the plant or someone who's using the things in the plant, you're just designing to not perhaps fully use it full time. And then for programmable, now you're just batch producing. This plant is not made for a specific thing. This plant is not made for a specific thing. It's made for many different things. So finally my hand gets some rest. It's not made for a specific thing. So that's what programmable is, which is why it's also lower cost. And those were my notes on page 19 of Unit 1. I should get back. That is automation in a nutshell. Oh my word. And here I was about to start, and then you've got all these 10 things that are true. Oh, it's 9. And some more. And some more. Let me just get back. By the way, this lo-fi music is actually helping, because when I try to study with no music, silence, okay. So generally my workflow is to work with music on, but it's different genres of music where generally I'm able to focus, but then today I couldn't. My mind was all over the place, business and so on. So I went with no silence, and that didn't help. Sometimes I took breaks to think about business. Sometimes I just took breaks to just clear my mind, and then try a bit of automation again, and then go back to that. So, but now when I'm doing this lo-fi, it's actually working pretty well. I'm just in the moment and studying. Chances are those also probably because there's a time limit and I need to sleep since I'm writing very, very soon. But you should try it out. This lo-fi is really working well, I would say. Link in the description below. Getting very hot. I ended up giving up on the theory part because I honestly speaking was not going to finish, and just decided to work on the previous tests and exams that we have, so that I actually know which part of the theory to work with and so on. Little side note though, if you want to get active, moving, healthy, whatever, get yourself a standing desk. It's an easy way to get yourself moving. When it comes to say standing, you get used to standing and so on. But movement wise, you just move. You move in times when you're not expecting to move, you just move and walk up and down. Sometimes you find me walking up and down this hall. It just happens. Right now I took off the blanket because I'm warming myself. So even if I'm cold, because I'm standing, I can easily move around. So that's easily warming myself, and those are some of the benefits of standing desk. Suppose if you're sitting down during exam season, getting cramped. A standing desk really helps. So little side note on standing desks. But back to the content. Calculations, which I also do not like for some reason. I don't know why I'm doing engineering, but I also do not like calculation. Nor do I like the theory. I like understanding the theory, but not cramming the theory, not doing the calculations. I just like understanding things. I say calculations are a bit lonely without music, or just very, very, very quiet, way too quiet. Ever since I got a calculator like this, I've never wanted to switch it back to that great calculator. Let me find it. Wherever it is. Well, I can't find it, so either I lost it or I threw it away. But anyway, ever since I bought this one, it has so many more features. I'll just put a picture up there so you guys know which calculator I'm talking about, the one that I had. The ones we use in high school that everyone knows. But this one, it's a much better upgrade with more features and so on. It's just much nicer to use. However, I'm not taking off my gloves for this though. It is very cold. Well, not so cold since I'm moving around, but my hands are freezing. 5 divided by 1 million. Why are we doing calculations like this? How am I supposed to find 5 times? Okay, wait. Finally! 1/2. So here's our track limit. So you've got that, you've got equal to. Okay, so you get a normal answer like that. Fair enough. What's the problem? Don't you just hate it when calculators do this? You're using a calculator to not calculate. Now you get an answer like this, and then you have to calculate. What if now you get your decimals wrong? I suppose it's part of the job. But anyway, that's not what's supposed to happen. I'm supposed to get 0,0. Supposed to tell me how many zeros I'm getting. Instead of giving me 5 times 10 to the power of minus 6. And now I have to calculate something else. I know how to calculate it, hopefully. But still. Basically, if you get 5 times 10 to the power minus 6, you should have a 0, a comma, 5 zeros, and then the 6th number should be the 5. Funny enough, I'm not noticing this music. It just happens once in a while, and I notice that it's there. But most of the time, it's just fading into the environment, which is weird. Though, the inspiration for this, though, was from an answer in progress video, which I have been binge watching lately in my no visual saga that basically, what I was replacing is now replaced by YouTube, and on YouTube, it's answer in progress. I'm kind of in the same place, but I'm not. Anyway, link is up there in the card, and highly recommend that you watch them. Wait, what am I doing? 30. This is 10. Not what did I do wrong? How many zeros? 1, 2, 3, 4, 5. 250. Did I calculate right? PID. Why? Konji, what's that other one? You gotta feel open, you gotta feel closed, you gotta feel. Feel what? Okay, fourth IR, as you all know, it is the fourth internet revolution, which basically means we had 4 internets before the internet we have now, which of course is false. The fourth industrial revolution, because we've had 4 different industries before now. If you ask me to name those industries, I have no idea. I suppose I do. It was there in the notes. We've got the steam engine, first industrial revolution, and then we've got factories, second industrial, and the third unnoticed, which I think most people forget about, was computers, and then the fourth we've got AI. Video coming on AI. I was about to say soon, but it's not coming soon. But it's coming. It's coming in September, July, maybe. We're doing June. September. Probably. If not September. What's after September? Wait, you've got August. Okay, it's coming in August or September. One of those. Anyway, fourth IR means fourth industrial revolution. And for these next questions, I have no idea what they are. Automated factory systems, vision systems, not Vinicius Junior, vision systems. You've got power supplies, you've got programmable logic controllers, servo driver systems, inverters, relays, and timers. Wait, what's the question? Programmable logic controllers, it is to, I have no idea. Servo driver, I have no idea. Inverters, I have no idea. Relay, I don't know. Timer is to time. Let's see what the memo says. Inverter to generate AC power from DC power electrically. Check out rundown we're releasing soon. We talked about Edison and Tesla, the inventors of AC and DC, and how Edison to prove that AC was not harmless, he electrocuted an elephant. All of that in the rundown episode dropping this Saturday. Today is Wednesday, so hopefully if I drop this on Thursday or today, that episode is coming on Saturday. Now the first test done and the 11th test to go. When am I going to finish? What time is it? It's 1. Doesn't look like I'm going to finish anytime soon. 15, 18. Okay. Minor load shedding happened. Don't know that. What? Wait. Don't do that. Solution. Right. So it turns out even Trevor is having problems. Asking him, this is still automation or we're doing English paper 2 literature. Even me at this point, I'm recording a YouTube video while studying because it's not going well. You'll see it tomorrow. I'll release it tomorrow or today. That's the only way I'm able to study. If I record a YouTube video, it will be released tomorrow. So it turns out even Trevor is fighting with automation at 1 p.m. AM on the 5th of June when we're writing 8:45. Okay. Vision system. What is a vision system? Hey, is here again. Okay, so what is a vision system? I forgot. PLC, I forgot. It's a servo driver. It moves, rotates, and processes based with high speed and accuracy. Right. You got an inverter which provides AC current, right? Your relays and your switches. That is probably wrong. This is 7 marks again. You got your relay and your timer. Now, your relay, it provides an output based on the input. Based on input it gets. The timer, same thing, provides an output based on input it gets after a given time delay. If I now use your energy via standing disk, like I said, you remove for no reason. But now at least I studied. If I sat down, I was not going to study at all. Which is weird, because generally what generally happens is that I'd sit down for days at a time. So let's say on Monday I sit down in the night. And you got Tuesday, same thing, Wednesday, same thing. And then by Wednesday I can feel my lower back has some pain. And that's generally what happens and how I know that I've been sitting down for too long. Whereas for now I sat down and I didn't get those signals. Probably because my body was tired. We wouldn't explain all this movement that I've been doing. But not tired. But I was somewhat doing some things, exercising, playing basketball, which will be released very soon. So subscribe. But probably why I didn't realize that I needed to stand up and things. But I would say things are getting in. I just have 9 tests to go.